Greetings, everyone. This is Mawin Nicole Reyes, together with my co-OJTs from UP Department of Geodetic Engineering, Jola Masa and Ashley Siervo. We will be sharing our preliminary analysis of Himawari 8 and AERONET data. Here is our presentation outline.
For the background of the study, solar photovoltaic device is used to convert energy from the sun into electrical using solar panels. PV panels are combined into arrays in a PV system that can either be installed in grid-connected or off-grid connections, which improve their performance. However, the performance of PV modules are influenced by different environmental factors such as dust accumulation. The suspended and deposited particle size has an important effect on the scattering and absorption of radiation incident on the solar module that results to lower PV module efficiency. Therefore, it is important to assess the impact of dust on surface solar irradiance. Aerosols are composed of suspended solid and liquid particles in the atmosphere. This causes reduction in solar radiation that reaches the Earth's surface. Aerosol optical depth is an optical parameter describing the extinction of solar radiation caused by aerosols. Variations in AOD can be observed in different seasons, climates, locations, and varying local factors such as emission and human activities. Angstrom exponent is a qualitative measure of aerosol particle size. Angstrom value greater than 1 indicates fine mode particles, while angstrom values less than 1 indicates the presence of coarse mode aerosol particles. AOD and AE plays a major role in categorizing dust particles and in computing the decrease in PV potential. Also, AOD and AE was considered in this project to be able to estimate the output properly and accurately. The solar path focuses on the assessment of available solar PV power resource potential in the Philippines, using high-temporal remotely sensed data that will consider meteorological and geomorphological aspects. The components will have an output of resource maps where the suitability of location for solar installation will be presented. So for the solar path component, Himawari 8 level 2 AOD and AE products are used with temporal resolution of 10 minutes and spatial of 2 kilometers. And the extracted parameters is the monthly mean AOD and AE for the year 2017 and 2021 that will be used for mapping of AOD and AE concentration in the Philippines.
The outsolar component quantifies the effect of high temperature, dust, and precipitation on the country's locally available solar PV models. The dust factor will be considered in developing a local forecasting model that will accurately predict the output power of solar PV installations in the country. Currently, we are in the initial stages of studying the dust effect and model on different satellites. The ground truth data we use are the level 2 cloud cleared and quality assured AOD at 500 nanometers and AE at 440 to 675 nanometers from the AERONET sites in the Philippines, which are located on Manila Observatory, El Nido, and Notre Dame in Coronadal. However, we excluded the El Nido sites since there are not enough historical data and temporal resolution to cover the duration of the study. Additionally, we also extracted the AOD product from the same sites with their pixel coordinates on the Himawari 8 aerosol model with AOD at 550 nanometers. For the mapping methodology done, the extracted AOD and AE data in the Himawari 8 product is clipped along the Philippine boundary. These data are then processed per month and annually across the years of 2017 to 2021. The maps shown are the mean monthly data from 2017 to 2021 of AOD property across the country. Here on this map, the monthly data from 2017 to 2021 is shown. The red pixels contain AOD data greater than or equal to 0.2, pink for data less than 0.2, and gray for areas with no recorded data. Similarly, in the next slide, these sets of maps exhibit the annual data from 2017 to 2021.
For the next slide, this map output shows the Himawari 8 angstrom exponent property mean monthly data for the year of 2017 and 2021. The maroon color represents fine mode aerosols with value of angstrom exponent greater than 1, and the peach one shows coarse mode aerosols with value less than or equal to 1, which shows coarse mode aerosols, and for the green one, no data present. Next is the is a map showing areas with fine mode aerosols only, with the blue one representing the fine mode aerosols and the gray one represents the Philippine boundary. And this is also monthly for the year 2017 and 2021. Next slide shows the areas with consistent fine mode aerosols for monthly data for the year 2017 to 2021. And for the highlighted parts in the left side, this includes Laguna de Bay, and for the right side, the mountain ranges in Bicol such as Mount Cabanbangan, Mount Pulong, and Mount Micomedia. This slide shows areas with coarse mode aerosols for the mean of monthly from 2017 to 2021. The red shows coarse mode aerosols and the green one shows the Philippine boundary. Next map shows areas with consistent coarse mode aerosols, and the highlighted part, the upper left, it is a place in La Paz, Tarlac, and in the right part, it is a place in Parang, Maguindanao, and the lower left part is a place in Tupi, South Cotabato.
Moving on to the outsolar component, first we analyze the AOD data from AERONET sites. On the plot shown on the screen, we use the mean of the monthly data and compare the pre-pandemic years of 2015 to 2019 and then the pandemic for 2020. For the Manila Observatory, during the pre-pandemic, the peak mean AOD values are during the hot dry season of March to May, exceeding the threshold of 0.2, which means the aerosol is heavily affected by dust. Then the low mean values occur during the cool dry season. Then during the pandemic, AOD values were now narrowing to a decrease to the halt of primary resources of atmospheric aerosols such as economic production, consumption activities, and transportation during the lockdown. Generally, it still follows the seasonality high mean and low mean from pre-pandemic. But what deviates from the trend during the pandemic is the peaking values on the months of September to October, which is around the easing of quarantine restrictions and follows an increase in human consumption activities than before, and of course January due to the New Year celebration. On the other hand, on AE, it matches the hot dry season of pre-pandemic with greater value or leaning to coarse particles, while to finer during the cool dry season. And then similarly, observed deviation from the trend during the year 2020 with peaking values in January, September, and October. Moreover, the particle distribution was found to be transitioning from fine to coarse throughout the years, with the frequency of finer particles concentrated at lower AO. The trend was also consistently observed in the Coronadal station, but here decreasing mean values during the pandemic year are more prominently observed, and then coarser particles exist in Coronadal than in Mesa. Next slide, please. Proceeding with Himawari 8 validation, to address the issue of varying resolution, we converted the AERONET AOD data to 515 nanometer using this equation to match with the available data for us in Himawari 8. The equation was adopted from study of Young in the evaluation of Himawari 8 aerosol products over Asia. Furthermore, AERONET AOD measurements with 15 minutes resolution were sampled to plus minus 30 minutes over time passed to match the Himawari 8 hourly AOD resolution. Then we extracted matching points of the same temporal resolution. Next slide, please. The resulting plots for the Manila Observatory and Notre Dame are as follows. The resulting R-squared were significantly low, so we are still in the process to validate if the point data we got from AERONET matches its supposed pixel location in the raster file of Himawari 8. And also other methods will be explored for AOD conversion and validation, especially with regards to resampling of temporal and spatial resolution. That's it for the preliminary analysis of Himawari 8 and AERONET data. Thank you.